strong axiom of reveal preference. Okay, we'll talk about strong axiom of reveal preference through an example, but before than that, let me just check warp. Is warp satisfied or not? I'll just give you an idea of what strong axiom of reveal preference is, but later on. So these are the three consumption bundles that you have: X, X dash, and X double dash at these prices: P, P dash, and P double dash. Okay. Now, let me just check whether warp is satisfied between X and X dash. Okay. So at prices P, X is purchased. At prices P dash, X dash is purchased. At prices P double dash, X double dash is purchased. Clear? Now, let me just check warp between X and X dash. So what is the expenditure on X at prices P? 12. Okay. Now, at prices P dash, at prices P, what is the expenditure on X dash? Again, 12. So you can say this, that Px is greater than Px dash, greater than equal to Px dash, which is fine. So 12 is greater than equal to 12, which is fine. Clear? Now, to be consistent with warp, when prices change to P dash, okay, then X should not be affordable. Okay, because you're choosing X dash at P dash, so X should not be affordable. Okay, so the expenditure on X at prices P dash should be more than the expenditure on X dash at prices P dash. So what is the expenditure on X dash at prices P dash? 10. What is the expenditure on X at prices P dash? 12. So this is what you have got, that is P dash X dash is less than P dash X. Okay, so this is consistent with warp. Hence, warp is satisfied, and you can say this, that X is preferred over X dash. Okay, this you have gathered. Now, let us check warp between X dash and X double dash. Okay, so it says this, that at prices X dash P dash, at prices P dash X dash is purchased. Clear? So when prices P dash, X dash is purchased and the expenditure is 10. When prices, at prices P dash, is X double dash affordable? Yes, because P dash X double dash is 10. So 10 is greater than equal to 10. So you have chosen X dash when X double dash is affordable. So it should not be the case that at some other prices, say P double dash, okay, X dash should be affordable when you are choosing X double dash. Okay, so it means that when you're choosing X double dash at prices P double dash, what is the expenditure, which is 17. Now, it should not be the case that at prices P double dash, X dash should be affordable. It should be greater than 17, and which is coming out to be 17.5. So P double dash X dash is greater than P double dash X double dash. So here also warp is satisfied. So you are choosing X double dash. Okay, you're choosing X double dash when X dash is not affordable. Okay, so between X dash and X double dash, you have concluded that X dash is preferred over X double dash. Clear? Between X and X dash, X is revealed preferred over X dash. Between X dash and X double dash, X dash is revealed preferred over X double dash. Between X double dash and X, when prices were P double dash, you're choosing X double dash. So what is the expenditure? 17. When prices were P double dash, is X affordable? Yes, it is 17. So 17 is greater than equal to 17. So you're choosing X double dash when X is affordable. Now, it should not be the case that at some other prices, say P, you should be able to afford X, you should be able to afford X double dash. Sorry, X. Okay. So in that case, what is coming out is that Px double dash is 13, okay, and Px is 12, okay. So you are choosing X double dash when X is affordable. So you're choosing X double dash over X. To be consistent with warp, what you should require is that Px double dash should be greater than Px, and this is what you are getting. So X double dash is preferred over X. Okay. So what you have done right now, you have done till here is this, that X is preferred over x dash. X dash is preferred over x double dash, and x double dash is preferred over x. This you have got. Warp is satisfied here, warp is satisfied here, and warp is satisfied here also. There is no problem with this. But in case if you look through these preferences, what you are getting is that x p x dash, p x double dash, p x. So it is violating. So this is wrong. This is not x, this is wrong. So this is violating transitivity assumption. Okay. So what you are trying to say is that in case if transitivity is satisfied, it should be that xp x dash and x dash p x double dash should have given you xp x double dash. But what you are getting is x dash px. You are getting this. Okay. Now, what is SARP? SARP takes care of this problem. Okay. SARP takes care of this problem. Okay. That is, SARP takes care that transitivity is not violated. If you are directly revealing your preferences and you are preferring one bundle over the other bundle and some other bundle over some other bundle, then the first bundle should be preferred over to the another bundle. So it is taking care of both direct and indirect revealed preferences. Okay, so SARP is basically taking care of both direct and indirect revealed preferences. So what you're trying to say is that if there is a bundle x1 x2, so if there is a bundle x1 x2 and which is revealed preferred over the bundle y1 y2, okay, either directly or indirectly, either directly or indirectly, okay, and y1 y2 is of course different from x1 x2. These are two different bundles. Then y1 y2, if this is there, then y1 y2 can't be revealed preferred over x1 x2 either directly or indirectly. Either directly or indirectly. It doesn't matter whether direct or indirect. So SARP is taking care of those indirect revealed preferences also. Okay. So see, you know this, that the underlying preferences of consumer, they must be transitive. So it follows that revealed preferences, they also should be transitive. Okay. The SARP is a necessary implication of optimizing behavior. Okay. If a consumer is always choosing the best things he can afford, then his observed behavior, it must satisfy SARP. Okay. So in case if the choices are satisfying SARP, you can always find the well-behaved preferences that would have generated the observed choices. Okay. So SARP is a sufficient condition also. So SARP is taking care of this. Let me just define it more formally for you, what exactly SARP is. So for any finite set of bundles x1 x2 and through xn, if x1 is revealed preferred to x2, x2 is revealed preferred to x3, and so on to xn minus 1 is revealed preferred to xn, then xn is not revealed preferred to x1. This is what SARP is saying. In our example, there were three bundles, x, X dash and X double dash. What SARP is trying to say, if X is revealed preferred to X dash is revealed preferred to X double dash, then X double dash should not be revealed preferred to X. This is what SARP is trying to say. This is your strong axiom of revealed preference. So what you have to do in case if you get a question like this, you will have to find whether you will have to find whether warp is satisfied between the first two bundles. Okay, and then it should not be the case that that the third bundle is revealed preferred over the first bundle. That is what SARP is trying to say. Okay.